morning, charms. Biggest offer of the year. So you can get 55% off on our CBSE subscriptions. So for that, you need to make use of the code UTSAP, and this is only valid till October 31. So please make use of this till, and this is the best time you can get this deal. And don't forget to use this particular code. Hello, budding charms. I hope everyone is doing well today. So we are back with the next one-shot session on the topic called sound. So please pay attention throughout the class and try to take down the important points. Not only that, if you find any kind of doubts in between, please don't hesitate to ask your doubts in the comment box. I'm here to help you out. So my name is Aishwarya Sindhu Ramachandran and I will be a science educator today. So let's get started. And now we are moving towards a part of content. So these are the various topics that we will discuss today. So let's dive into the part and look at it. We are going to start off with the basic definition of sound, then human sound, structure of human ear, characteristics of sound. This is a very important part, so we have to concentrate a lot more in this part. Then we'll discuss audible and inaudible sounds. Finally, noise pollution. And look at it. What are the different sounds that we hear on a daily basis? Oh, let's take some examples. Bird sounds, then machine sounds, then human voices, music, different types of noises from factories. Oh, all of these can be considered as various sounds that we hear in our day-to-day lives. But how these sounds are produced? That's a very big question, right? Yes, that's what we are going to learn now. So sound is produced by vibrating objects. So sounds are produced when objects vibrate. But where? In a medium. Very, very important. Okay, so sound is produced by vibrating objects and sound waves need a medium to propagate. That is a very, very important point. So if sound has to propagate, a medium is very much essential. Imagine there is no medium. Will sound propagate? No. Sound cannot propagate without a medium. This is what the same situation happens in space. When astronauts go to space, they cannot speak each other. Why? Because there is no medium in this space. So they use radio waves to communicate. Got it? So you have to understand that if sound has to travel, a medium is very much necessary. In space, it is completely vacuum. Therefore, sound cannot propagate in space. And what about this one? It travels from one place to another in the form of mechanical waves. So sounds are considered as mechanical waves. Why? Because it needs a medium to propagate. Very, very simple. So it can travel from one place to another through a medium. And now we are going to take some examples on this. Look at it. Horn, tuning fork, guitar. All these objects are able to produce sound when they vibrate in a medium, right? Yes. So let's take the example of tuning fork itself. If tuning fork has to make a sound, it needs to make vibrations. So due to these vibrations, sounds can produce. The same goes with the part of guitar. Guitar has a lot of strings, right? So if you just try to strike these strings, yes, it produces sound, right? Yes. And now we are going to talk about the difference between transverse wave and longitudinal wave. What are these? Let's find out. So transverse wave. Particle motion is perpendicular to the direction of propagation of wave. What is that? It's a bit confusing, right? Don't worry. Let me break it down for you. So if you consider the particle motion, so the particle motion is in the upward direction. So I'm putting it as PM, particle motion. And what about the wave propagation? Wave propagation in this direction. So wave propagation, WP, is happening in this direction. So when you look at these two directions, you can say that particle movement and wave propagation are perpendicular. Right? So the particle motion is happening perpendicular to the direction of propagation of wave. At this point, we can call this wave as a transverse wave. What are the different examples on it? Surface ripples on the water, electromagnetic waves. All of these are considered as various examples of transverse wave. What about longitudinal one? Particle motion is parallel to the direction of propagation of wave. So very, very simple. Particle motion and wave propagation. Both are parallel. Got it? At this point, you can say that it is a longitudinal wave. But when you look at this, you can see that there are two pressure regions which are formed. What are they? Oh, this is nothing but the compressive region and rarefaction region. Very, very important. Clear? So when you look at it, you can say that rarefaction and the compressions are the different pressure regions that are forming in a longitudinal wave. Clear? So these are going to be formed alternatively. How? Let me tell you. So if there is a compressive region, then the next one is going to be a rarefaction region. So here again a compression region, again a rarefaction region. Again compression, again rarefaction. So this is the way in which different pressure regions are formed in a longitudinal wave. Clear? What are the different examples? Ultrasound and the vibration of a spring. Both of these are considered as examples of longitudinal wave. And now what we are going to learn is all about how do humans produce sound? I speak here, but how I am able to make the sound? Let's learn. Okay, so for that you need to understand there is something called larynx here. So at the upper end of my windpipe, there is something called larynx. So larynx can also be called it as voice box. So this voice box has two cords which are stretched like rubber bands. And there is a slit in between. So this is a slit through which the air passes into. Got it? So when air pushed into the part, what happens? These cords can vibrate. And that is what the reason I'm able to make my sound or voice. So if there is a vibration in the vocal cord, the sound is produced accordingly. So this is what about the production of human sound. And now what we are going to learn is all about structure of human ear. Oh, that's a very important one, right? I'm able to speak here, but you should listen to my class, right? For that, you need an ear, correct? Yes. So ear is very, very important in our day-to-day lives because we need to have the sense of hearing. So when you look at this, it has mainly three parts. So when you take the structure of human ear, it has outer ear, middle ear and inner ear. But what are the basic functions of ear? Sense of hearing and maintenance of sense of balance. That is also an important function of our ear. And I told you that there are mainly three parts in our ear. But what are the different parts associated with it? What are the various functions of it? Let's learn together. So now we are going to learn about outer ear first. Oh, what is the outer ear? The external part of your ear. So this has mainly two parts. What are they? Pinna and auditory canal. What is pinna? It is made up of cartilage, collects sound waves and direct towards the auditory canal. So this is pinna and this has a function of collecting the sounds and transmitting it to the part of auditory canal. Oh, that's a very, very important thing, right? But pinna is made up of cartilage and auditory canal is a tube-like structure which has wax glands. And therefore, what happens? The sound can get transmitted into the middle ear. Look at it. From outer ear to the middle ear. So, in the outer ear, there are two parts, pinna and auditory canal, through which the sound transmit into the middle ear. Clear? Now, we are going to talk about middle ear. So, middle ear also has two parts, eardrum and ear ossicles. What is eardrum? This can also be called the tympanic membrane. Okay, so when sound hits this particular eardrum, it starts to vibrate. Very, very important. Okay, and what about ear ossicles? Malleus, ingus and stapes. So these three bones transmit and amplify the sound vibrations. Whatever the sound vibration has been produced by the eardrum needs to be amplified. So this is done by ear ossicle. So the vibration from the eardrum get transmitted to the inner ear. Clear? So now we are in the middle ear. Now the sound again has to be transmitted towards inner ear. So that is where we are going to learn about inner ear. So inner ear also has two parts. What are they? Cochlea and auditory nerve. What is the function of cochlea? Cochlea looks like a snail. Okay, so the snail-shaped organ filled with a fluid. So it is having a fluid. Okay, and this is lined with tiny hairs, and when sound enters the fluid vibrates. So when the fluid vibrates, the tiny hairs also start to vibrate. Then what happens? These have to be transmitted to the brain. But who is doing that job? It's doing by auditory nerve. So auditory nerve carries impulses which are produced inside our inner ear to the brain. That's what the main function of auditory nerve. Clear? So I hope you're clear. And now we are moving towards the next one. It's all about how do humans hear sound? We know that, right? Very simple, because we already learned all the parts. So outer ear pinna collects sounds from the surroundings and make the sound passes through the tube called auditory canal. Then when sound hits on eardrum or tympanic membrane, it produces vibrations. Vibrations sent to the inner ear and from there to the brain as signals through auditory nerve. So this is the way that you need to connect all the parts. Pinna, auditory canal, eardrum, ear ossicles, cochlea, auditory nerve, and finally to the brain. So this is the pathway of sound reaching our brain. Clear? So now what we are going to learn is all about the characteristics of a sound wave. Very, very, very difficult part. So please listen carefully. So there are mainly 4 things that we need to understand here. Okay? Amplitude, frequency, time period, and wavelength. So these 4 characteristics are very important for a sound wave. When you consider a wave like this, it has mainly 2 parts. The upper portion can be called it as crest. Please remember these terms. Very, very important. And let me take a different color for the trough. Okay. So the lower portion of the wave can be called it as trough. Okay. So please understand the terms. The upper portion can be called it as crest and the lower portion can be called it as trough. And now what we are going to learn is all about the characteristics in detail. So let's discuss about wavelength first. What is wavelength? The distance between 2 consecutive crest or trough of a wave. So there are 3 ways in which you can measure the wavelength. Let me tell you one by one. So the first case, I am taking the midpoint of 2 consecutive crests. So let's see how it is going to be. So this is a midpoint of the first crest and this is a second midpoint of the second crest. Clear? So the distance between these 2 can be called it as wavelength. This is the first way of measuring the wavelength. Clear? And now I'm going to tell you the second type of measurement. For that you need to consider 2 consecutive troughs. So here is a first trough, here is a second trough. So the distance between these 2 can be called it as wavelength again. Clear? And what about the third method? For that you need to consider a crest and a trough. And now look at it. This is the crest and this is the trough. So if I want to measure the wavelength, I have to take the total length of one crest and one trough so that I will get the lambda wavelength. Clear? So lambda is a letter that we use to represent the wavelength. Clear? So these are the 3 methods in which you can take the wavelength. What about its SI unit? SI unit is meter. Clear? So I hope you're clear with the point. And now what we are going to learn is all about amplitude. What is meant by amplitude? Maximum displacement from mean value is known as amplitude. Which is mean value? This is known as mean value position. Okay? So from there, you have to consider the dotted lines. And this is known as amplitude. Clear? So this can be considered as amplitude. Okay? So if amplitude is high, loudness is also high. A very similar relationship between amplitude and loudness. So if amplitude seen to be high, then you can say loudness is also going to be high. Clear? That's what about amplitude. But don't forget about the SI unit. It's meter again. Okay? So now we are going to talk about frequency. What is meant by frequency? Number of oscillations per second. How many oscillations are produced in a second? Clear? Then you get a doubt. What is meant by oscillation? One oscillation means one crest and one trough. Clear? This is called one oscillation. Okay, so number of oscillations per second can be called it as frequency. In 1 second, how many oscillations are produced? This can be called it as frequency. And what about its unit? It's nothing but hertz. What is time period? Time taken for one oscillation. I told you what is one oscillation, right? Yes, one crest and one trough. Correct? Whatever the time that is required to complete this one oscillation can be called it as time period. Clear? If I want to complete this particular oscillation, how much ever time I require, this can be called it as time period. And there is a relationship between time period and frequency too. They have a reciprocal relationship. What is it? Time period T equals to 1 by F. F is nothing but the frequency. Clear? This is what the relationship between time period and frequency. And what about its SI unit? Second. So don't forget about it. Very, very important. And now we are going to talk about the relationship between amplitude and loudness. We know that, right? But still we are going to revise the points. So look at it. If the sound is quieter, you can say it has less amplitude. Look at the distance here. From the mean position, the maximum displacement is less when compared to this one, right? So that you can say this is quieter, which has a less amplitude. Look at this one. Oh, the maximum displacement is more here, right? From the mean position, it is more. Therefore, you can say that it's nothing but a louder sound, which has a more amplitude. Clear? So, if the wave has less amplitude, then you can say the sound is going to be quieter. If the amplitude is more, then you can say the sound is going to be louder. Clear? Clear with the point? Similarly, we have to revise the relationship between frequency and pitch. Look at it. Less frequency. Number of oscillations per second is less here. So that the pitch is also going to be less. What about more frequency? More oscillations are seen. Therefore, it has higher pitch. Clear? I hope you're clear with the point. So, if there is less frequency, lower pitch. If it has more frequency, it is higher pitch. This is a way that you need to connect it. And quality of sound is determined by pitch. So, female voices are higher in pitch than male voices. So, when compared to male voices, female voices are high pitched. Clear? So, I hope you're clear. And now we are going to talk about audible and inaudible sounds. Oh, what is that? We cannot hear all type of sounds, right? There is a specific range for it. So, based on the frequency, we have to understand whether the sound is audible or inaudible. That's what we are going to learn now. So, audible sound range, that means the sound range in which humans can hear. So, the range of sound that humans can hear can be called it as audible sound range. So, this is nothing but 20 Hertz to 20,000 Hertz. That's the range here. And what about infrasonic and ultrasonic? These two sounds are inaudible sounds. Please don't forget it. Very, very important. So, these two are considered as inaudible. Why inaudible? Because these are having a different ranges from the audible sound range. Clear? So, infrasonic, we cannot hear that. Why? Because the sounds that have frequency less than 20 Hertz. So, if the sound range is less than 20 Hertz, we cannot hear it. But elephants and whales can hear it. And that is what the reason we call it as infrasonic sound. Clear? Earthquakes can be formed due to the seismic waves. So, these waves can be listened by elephants and whales. Clear? Similarly, when you talk about ultrasonic sounds, what are they? These sounds also cannot be heard by us. These sounds that have frequency greater than 20,000 Hertz. That means we can say that it's very, very higher than the audible sound range. Therefore, we cannot hear it. But who are producing these? Bats. So, bats are producing these ultrasonic sounds. We cannot hear it. When you look at bats, they simply fly. But still, they are actually making sounds like these. Clear? I hope you're clear with the point. But we are not able to hear because these are not in our audible range. Clear? And now we are going to talk about noise pollution. The presence of excessive unwanted noise in our surroundings can be called it as noise pollution. So what are the different problems associated with it? hearing impairment, hypertension, and sleeplessness. Music is so pleasing to us. But what about noises? Oh, it's very unpleasant in nature, right? So this can cause pollution and cause these kind of issues too. But what are the control measures? Planting trees, reducing noisy operations. So these can be considered as two control measures that can be introduced to reduce the noise pollution. Clear? So now we are going to summarize the points what we discussed today. Started with sound production, human sound, structure of human ear, characteristics of sound, audible and inaudible sounds, and finally noise pollution. And I hope everyone really enjoyed the class. So that's all about today's class. We'll see you next class with an amazing session similar to this. Have a nice day and goodbye everyone.